Okay, types of chemical reactions. Let's talk about combination or synthesis reactions. You have two reactants forming one product. So, for example, reactant A reacting with reactant B to produce product AB. Let's look at an example of a combination or synthesis reaction. Here we have a reaction for the synthesis of ammonia gas. Nitrogen gas combined with hydrogen gas give ammonia gas. I'm leaving out the states of matter just to simplify the balancing process, okay? Now, let's balance this equation. We have two nitrogens on the reactant side, and on the product side, we have only one nitrogen. So let's put a coefficient of 2 in front of the nitrogen on the product side. And now we have the nitrogens balanced out. All right, now let's go over to hydrogen. We have two hydrogens on the reactant side, but on the product side we have 2 times 3, we have 6 hydrogens. Okay, so we need to balance out the hydrogens. Okay, remembering our times tables, 3 times 2 will balance out to 6. Okay. So 2 nitrogens on each side and 6 hydrogens on each side. Let's balance another equation that is also a combination or synthesis reaction. Let's look at the reaction for the formation of aluminum oxide. Aluminum, over a lot of time, will react with oxygen to form aluminum oxide. Aluminum is a metal that doesn't really undergo corrosion too readily, but when it does, forms aluminum oxide. Okay. So we have 1 aluminum on the reactant side, and on the product side, we have 2 aluminums. So we need to balance out the aluminums first, okay? 2 aluminums. Okay. All right, then we have 2 oxygens on the reactant side, and on the product side, we have 3 oxygens. Okay, well, we could do our times tables. 3 times 2 is 6. So let's put that here, a 3 and a 2, so that we have 6 oxygens on each side. Okay, now let's go back and check. 2 aluminums, 2 times 2, 4 aluminums, because that 2 helped to balance the oxygen, but now it also changed the number of aluminums. Okay. So we need to go back and change this coefficient to be a 4. Now, 4 aluminums, 6 oxygen, 6 oxygen. We need to keep in mind that in nature, the law of conservation of mass holds. Okay? We are tempted to make it fit what we want it to fit and erase subscripts and say, all right, well, you know, I had 2 over here, and why can't I just delete that and keep that 2? No. Okay? When we balance equations, we only can use coefficients, and we see that in the process of balancing that sometimes we get one thing balanced and it upsets the balance of something else. Well, we need to modify that and correct it, because in reality, the balanced equation is what occurs. Okay? So I see students sometimes, they want to so bad change the subscripts and get frustrated and say, well, why can't I just do this? And why, don't get frustrated. Calm down. Okay, take a break from it if you were looking at it for too long. Okay, but this is what happens in nature. 4 aluminums react with 3 oxygens to result with 2 aluminum oxides. That's the reaction. Okay, you can't make it fit to how you want by adjusting subscripts. You can only balance by coefficients. Okay. All right, so let's do some more examples of types of chemical reactions and balancing equations along with it. So you have combination reaction, where you have 2 reactants come together to form one product. Well, the reverse of that is a decomposition reaction, where you have one reactant that's broken down into multiple products. It's broken down into what made up the reactant. It's the reverse. Okay, so let's do decomposition reactions. Okay, decomposition. One reactant is broken down into 2 or more products. It's the opposite of combination synthesis reactions. You have some reactant in the form of AB breaking down into products A and B. Let's look at an example of a decomposition reaction. Let's look at the reaction for the decomposition of hydrogen peroxide. Hydrogen peroxide over the counter is a 3% solution stored in a dark brown bottle, and it's advised to keep out of light and to keep the container closed because over time the hydrogen peroxide slowly, without the presence of a catalyst, will break down into water and oxygen. So in theory, if you left that bottle of hydrogen peroxide opened over time and did nothing to it except let it sit out, you would eventually be left with a bottle of water because all the oxygen would would react out. It would decompose, okay? This would decompose. A reaction in lab that can be done to speed up the production, the decomposition of hydrogen peroxide is by using a catalyst. If you use this catalyst, it's a black powder catalyst, and it very quickly speeds up this decomposition reaction so the oxygen vigorously bubbles out. It goes, whoo, you know, and what you're left with in the test tube is just water, and the catalyst settles to the bottom over time and could be filtered out. But basically, that's when you buy the hydrogen peroxide bottles, that's why it's stored in a brown container, so it's not affected with light to slow the decomposition down, and that's why the bottle says to keep it closed, okay, so that this doesn't happen, and you have what you intended to have, hydrogen peroxide. Okay, let's balance this equation. Okay, two hydrogens, two oxygens, 1 plus 2, 3 oxygens. You say, can't just do the times tables here because I have oxygen, 2 products. Okay. The lowest coefficient that you can place on the product side would be a 2. Start with the lowest coefficient. You say, well, I need to balance this out somehow. So if I put a 2 over here, okay, it's going to give me 4 of everything. 4 hydrogens, 4 oxygens. So you say, all right, well, if I put a 2 over here, because I have to balance out hydrogen, that'll give me 4 hydrogens. What happens to your oxygen? 2 times 1 is 2, plus 2, 4. Always start at the lowest coefficient. If 2 didn't work, go up to 3. Okay, don't just start with the highest number or some random number. Start with 2. If 2 doesn't work, go to 3. Okay? Start with the lower ones. So decomposition is the exact opposite of combination synthesis. Okay, and I had another example I gave you, decomposition of potassium chlorate in a few minutes in the previous video. Okay, that was a decomposition reaction as well. Okay, another type of chemical reaction is a single replacement reaction. Let's look at that type. Okay, let's look at single replacement reactions, also called oxidation reduction. In this type of reaction, you have one element replacing another element. And it follows either that a cation replaces another cation or an anion replaces another anion. Okay, the same type replaces the other type. Okay, the same type of itself. A cation, cation, anion, anion. Okay, so that's what happens in here. So just a general format. Here's an example of just general, when the cation is replaced, let's say A is a cation, maybe it's hydrogen, maybe it's a metal, and in the ionic compound that it's reacting with, it's going to bump out the other cation and then join up with the other anion, okay? Because cations need to be paired up with anions. In this example, in this scenario, an anion will be replaced. So let's say that B represents some non-metal. Maybe it's a halogen, okay? Maybe it's nitrogen or oxygen. And it reacts with some ionic compound, okay? And the anion is being replaced, so the cation A will pair up with the other anion to give you product AB. Okay. Let's look at two examples, one where the cation is being replaced and one where the anion is being replaced. Okay. In this single replacement reaction, you have hydrochloric acid reacting with the metal aluminum. It's a very common reaction. Acids will react with pretty much most metals. Gold's one of the few that it doesn't really react with too much. So let's look at the reaction for hydrochloric acid and aluminum to produce hydrogen gas, which would bubble out if you were actually doing this. And one of the online labs, you'll see a similar reaction of a metal with an acid. So you'll at least get to see a depiction of that. And then what is also produced is some ionic salt in aqueous solution. In this case, aluminum chloride. Let's balance the reactions. Okay. Try to tell you what some of these things are so it's not so boring, just balance, 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 count, count. You know, it's good to hear about what some of this stuff really does and what it looks like. So trying to keep it a little bit interesting as can be. Okay, let's see. 1 hydrogen on the reactant side, and on the product side, 2 hydrogens. So let us put a 2 over here to balance out the hydrogens. Okay. Remember, use pencil, okay, or erasable ink so that if you need to change something later on, you can do it nice and neat, okay? 2 hydrogens, 2 hydrogens, okay. 2 chlorines, 3 chlorines. Oh, already have changed the coefficient. Well, if this is 3 and I have 2 here, you say, well, 2 didn't work, so I probably should go up to maybe try 3, okay, because 2 didn't work to balance out the chlorines. So try 3. Okay, let's try it out. 3 hydrogens, 3 chlorines. Well, over here, I can't put a 3 here. I have a 2. So what do? You have this 3 and 2 going back and forth. What if we make 6? Let's erase all this. We know 2 didn't work. We know 3 didn't work. But if we put the 3 here and the 2 there, okay, so we have 6 hydrogens and 6 chlorines. We'll put 6 there. 6 hydrogens, 6 chlorines. Now, why am I doing this? Because this is the thought process that goes through a lot of people's heads when they first start to do this, okay? So I'm trying to mimic what I think that some people are thinking because I've known from teaching this some of the questions, okay? Start low. If it doesn't work, go up, okay? But those times tables come in, okay? Remembering those times tables. If you have 3 on one side and 2 on the other, you got to make it 6 to balance out. All right, now we have 6 and 6 of hydrogen, of chlorine. Let's go to aluminum. 1 aluminum, 2 aluminum. Aluminum's all by itself over here, so I could put a 2 there, and it is balanced. Okay, these are the lowest set of coefficients. You cannot reduce them to any lower whole number. 6 hydrogens, 6 chlorines, 2 aluminums on both reactant and product side. Okay. Let's do an equation of a single replacement reaction where the anion is replaced. Okay, here the cation was replaced. See, the hydrogen replaced the aluminum. Okay, so you see that this is what happened here. That's where that cation was replaced. Okay, the aluminum said, no, I'm pairing up with chlorine, hydrogen, you're out. Okay. Let's see where we have the anion replaced. Let's do an example of balancing equation with that. All right, in this type of single replacement reaction, the anion is replacing the other anion. Okay, the chlorine is a nonmetal forms an anion. It's bumping out the bromine and pairing up with sodium. Okay, so it's a single replacement reaction. One anion replacing another anion. Now let's balance it. Okay, we have 2 chlorines on the reactant side, and on the product side we have 1 chlorine. So let's put a coefficient of 2. Now we have 2 chlorines. Okay, 1 sodium on the reactant side, but we have 2 sodiums on the product side. We need to put a coefficient of 2 to balance out the sodium. Bromine, 2 bromine. Now coefficient of 2 applies also to the bromine. And 2 bromines on the product side, balanced. Okay. The next type of reaction is double replacement. So we'll see double replacement reaction in the next video, and combustion reactions we'll see also in the upcoming videos.